control of that computer. Okay, so all the zero-day exploit, all the things that will be written in future, the whole idea of that is actually to kind of control this specific register value, nothing else. Okay, so that's it. So now let's proceed with further discussions. So as I told, so thing is that those register values, the one that kind of I'm showcasing right now over here, they all have kind of their specific meanings. Okay, you can kind of you can treat this just kind of a memory slot, that also work. But in the Windows operating system, or let's say Linux operating system or Mac operating system, all these memory slots has their own kind of a specific meaning. Okay, and what the meaning is, like the EAX, it's called accumulator register. It is actually used to kind of store the operands value and result data. And what I mean by operands and result data is this one. So let's say a equal to 10. Okay, so this is something, let's say, is kind of an operand like a. Okay, and the value is stored in EX. Okay, it is getting stored. Now what this thing is telling, result data, I mean, when you are doing a equal to a plus b, the CPU will normally store that result whenever, let's say, is there any calculation, the result is getting stored. It will always kind of try to store that result only in the EX register and not in anyone else. Okay, so that's why that it's very important. That's what the importance of EX register is all about. It's all about, because why it is more important, because if there's any kind of result that is returned by any kind of line of code, it's always, most of the time, is always stored in the EX register. Okay, you can store it anywhere else, that's completely fine. But in normal sense, you can specify, let's say I want to store the value in EDI, or let's say I want to store the value in EIP. That's all fine, you can do that. But in most of the time, what happens is that the value will be stored in EAX register. Okay, so now the next thing is the EBX register. It's something you will kind of which will make much more sense in the stack when we're kind of dealing with the memory part. But normally it's called EBX register, which is also called a base register. ECX is the counter register, as I told, whenever you're dealing with, let's say, any kind of looping kind of thing. So the counter, let's say the next time 1, 2, 3, 4, what's the count? So that count is actually stored, is tracked actually in the ECX register. Okay, and similar way, there are multiple other registers like ESI, EDI, data pointer register to memory operations. So this is actually like ESI and EDI. Let's say I am storing certain thing. Let's say a equal to a plus b. I'm storing, let's say, certain thing, or I'm fetching certain lines from the memory itself directly. Like, let's say I'm storing, let's say in this memory there is a specific space over here in this memory. Let's say the address of this is ABC. Okay, so I can even specify that ABC memory slot is equal to a plus b. So the data will be directly stored of this output into this value, the memory slots. Okay, so this is where the ESI and EDI will play a more amount of role. Today we'll be more worried about the ESP register, which is actually pointing the stack memory. That will kind of try to understand what is stack is all about. We'll try to understand that. And then there is the EBP register, which is all about kind of fetching the values from the stack. Okay, so this will make much more sense as we proceed with the discussion. But thing is that this is kind of a general overview of like what the meaning of this all registers, like EX, ECX, and all other things. And EIP you already know about in detail. Okay, so now let me go to the next slide. Okay, so now one thing, guys, thing is that there is one more thing. So if it also depends, like the EX, it's EX, EBX naming convention of this memory slots. It also depends upon what kind of CPU you have. Is it 64-bit? Is it 32-bit? Is it like 15-bit or 16-bit? So if in case the system that you are using right now has 32-bit CPU, just remember this word. If it is, then the register will be named as, so why it is called 32-bit CPU? Whenever we say, like, let's say whenever we say that, okay, it's a 64-bit CPU, it's a 32-bit CPU, the core thing is why we say that is because this memory slots that you are seeing over here, the size of this storing capacity is 32-bit. Okay, and that's why in normal sense why we say that, okay, a CPU is let's say 32-bit or 64-bit. So in a 32-bit CPU, you can store there. So each register will have a space of 32-bit storage. Okay, so you can store any data in this, let's say in the EX register at a time of 32-bit in place. So let's say I want to store 5. So I can mention this 5 as, let's say, 4 bytes. I can say this as 0, 1, 0, 1. Okay, so this is the binary representation of the decimal 5. Okay, and now this is consuming only 4 bits. Only 4 bits. This is of only 4 bit 0, 1, 0, 1. Okay, so this 4-bit will actually fit out in this 32-bit. Now let's say I have a number like let's say 20 for example. Okay, so the binary value of this will be 0, 0, let's say 1, 0, and then 0, 0, 0, 0. So the decimal 20 will be in binary will be 0, 0, 0, 1, 0 and 0, 0, 0, 0. And this data, it is of 8-bit and it can fit out in this 32-bit section. Similar way, if there are calculations like numbers, let's say of a very big value, so it will depend upon how much data can be stored in this one. So that's where the thing is that you need to kind of that's where the kind of constraint come. So in a 32-bit, let's say you can only store those numbers or decimal values or any string values up till 32-bit of space. Okay, you can't store any number. Let's say the number is, for an example, the number is, let's say that we want to store is, let's say 3, 4, something like this, like big number. Okay, so if you convert this big number into binary, it will be huge. It will be, so this number, let's say this big number, the binary value of this one will be really huge. And as you know, guys, computer only knows 1 and 0, only the binary values. So thing is that this binary value will be stored in this one, and when the CPU will try to fit this out in this 32-bit, thing is that it will not be kind of fitting in this register because let's say the bits value, let's say, is of 64-bit, for example, rather than 5 being only of 4 bits or 20 only being of 8 bits. Let's say this huge number is of 64-bit, so this won't fit into this EX register. Okay, and that's what the limitation comes up, and that's why this is called like that's why when we say like CPU, we are purchasing a system which has 32-bit CPU, we need to keep this in mind that a huge calculation will not be possible in 32-bit CPU, and it will take time for the system that is running on that CPU to kind of do that calculation. So what will happen in that case, the 32-bit will be stored, let's say, in EX register, and the other half of 32-bit will be stored in, let's say, other register like EDX. So it will slow down the calculation, and that's how thing is that these are the kind of limitation that comes up in a 32-bit CPU. If it was a 64-bit CPU, the space of this EX register will be additional 32 bits. Okay, so you can store a number, let's say this huge number, directly in the EX register, and this will make the calculation a little bit much faster. Okay, so I hope, guys, I am audible and you guys are able to understand what I mean to say. So this is all about kind of like what. So this is all about the 32-bit and 64-bit. So here the thing is that, let's say we are dealing with a 32-bit system. So over there, the EX register is all about kind of like let's say. Okay, so let's say this is the EX register, and the EX register is like it's a 32-bit. Okay, So now the thing is that what happens, let's say when we are dealing with a 16-bit